On this episode of the Tech Junkies, we're going to take this monster truck, fit it with this GPS module, control it with this microcontroller, and have ourselves an autonomous GPS vehicle.
Yup. Hey, the new episode's ready. I'll be there in 10 minutes. Alright, I got the new episode.
Great, let me see the thumb drive.
It's right.
Where is it?
It was here.
Uh-oh.
Alright, the goal of this project, like we just said, is we want to take this RC car, and we're basically going to convert it into a GPS navigation robot. So to do this, we're going to need a few components. The first one is this GPS chip. You can get this on sparkfun.com. That's actually where we buy most of our electronics. And if you look down here, you'll be able to see the website address where you can buy that at. This is about 60 bucks. And this is a 20 channel receiver, which means it can connect to up to 20 satellites simultaneously. And you're never even going to need that much, so this will pretty much do any GPS project you're going to need. Another thing, we really like these Arduino microprocessor boards. These use an Atmel microprocessor chip on them, and they're really easy to program. If you're just getting into programming, they're really easy to start learning your way around programming and whatnot. So we bought one of these chips. This is what we're actually going to write our code to, and this is going to control our robot. So we're going to mount this inside the robot, supply power to it. For supplying power, we're actually just using a 9-volt with 2 leads coming off it, power leads. And this has a built-in voltage regulator. This runs on 5 volts. This is 9 volts, so you just feed this in right here, and this will regulate it down to the voltage it needs. One other thing we're doing, if you look inside one of these cheap cars, this is just a $15 Radio Shack special. You'll see that we don't have it open right now, but there's actually a motor here for the steering. Now this can be a little slow, it's not all that responsive, and it's not all that accurate. And to make our job easier, we're going to be taking a servo, and this will allow us to position the steering exactly where we want it, and this is a little bit faster too. So we're just going to rip out the motor inside here, take the servo, mount it in there, and then we can connect this directly to our Arduino microprocessor. And we'll be able to control steering really easily. However much we want to turn the robot, we can be doing that with the servo. And then one last thing, you see there's a motor back here that actually drives this RC car. We're going to be taking control of that motor. We're just going to be ripping all the electronics out that are in here, basically just using it for the chassis. And we have this, it's called an H-bridge chip. You can also get this on sparkfun.com at the address right down there. And this chip will basically let you take inputs or outputs from the Arduino, send them to this chip, and this chip will handle all of the power from your batteries to your motor, so you can turn the motor forward, reverse, or whatever you want. And this is what's actually going to let us control the power for the drive. So we're going to connect all this stuff together, and we'll see how it goes.
And to make this a success, the goal is to make this robot autonomously drive to 3 different waypoints and then come back to its original point. And if we can make it do that all by itself, we'll consider this build a success. So let's try it out.
Okay, so we just took our quick JB Weld. This stuff dries in about 5 minutes. And now that we've got the RC car ripped apart, we tore off the old motor, and here's our new servo, and we just let this dry. And now you can see when the servo moves, our wheels are going to move. So now we just connect this into our microcontroller here. We've got everything pretty much set up with a breadboard here, so we can easily connect everything up here. Okay, so we just finished wiring up our H-bridge here on our breadboard, and it looks a little chaotic. We'll have a write-up on ttjcrew.com on how to connect this all up. But we have the basic code on here for driving the H-bridge, and we're just going to power up our Arduino microprocessor here and see if we can get the wheels running on our RC car. So let's apply this here. And there we go. H-bridge is running, and our microprocessor is now telling these wheels to spin. And we also have control of the servo now as well. So all that's left is to put the car back together and give it a shot. Okay, so we are reassembling the car right now, and we've got most of the electronics back together. So you can see we've got the servo right here, got all our connections coming from the battery and the motors. This is going to get reconnected to our breadboard. And now we just have to mount all our electrical components right inside the chassis here. Okay, so we just finished reassembling our RC car here. We've got the GPS module up here on top. We've got our Arduino microprocessor right down here. We've got all our connections fed through here and into the Arduino. And we've got our little 9-volt connector here for powering up our Arduino. And if you can hear, the servo is actually rotating, so we've got servo control. And there's our motor. So when we power this up, we've got this pre-programmed. It should center the wheels, and it should run this forward. So I'm just going to move this off to the side. Take our 9-volt here. Connect it in. There you go. It centered the wheels, and it's now driving forward. So all that's left is to take this thing outside, set up our GPS coordinates, and see if it can do some navigation. Okay, so now we're going to load the coordinates into our robot for what we want to navigate. And right here we're just in Google Maps, and you can just right click on any location. We're going to go down to the local mire for this one. And you can just click center map here, and then there's this little line of JavaScript that we'll have on the site. And if you enter this in your address bar right here, you'll get a pop-up box with your latitude and longitude in degree decimal form. And this is exactly what we need. So now we're just going to draw in some waypoints and load these coordinates into the robot, and then drive down there and see how it works.
Yep.
Okay, so we've got the coordinates loaded in. Let's power it up and see what happens. Here you can see the RC car was weaving and turning all over the place. For this take, we had just replaced the batteries in the RC car, so our turning values were quite a bit too sharp. As the batteries wear down, you'll see the car return to how it should behave.
Oh no, not under the car! Oh, fail.
The navigation program that is running on the microchip is actually quite simple. The GPS chip gives us a serial input of data, and we're just using the Arduino NMEA library to read in this information. From there, we just had to determine what our heading should be and manipulate the car accordingly. Make sure to visit ttjcrew.com for a full copy of the code and an explanation.
That's it. It stopped. Nice. Pretty close to the stop sign, too.
Now that we've drained the batteries a little bit, we're going to go try and do a round trip around the block and see how it goes.
And now the car is leaving. Should turn right any second. There it is. Nice.
That was awesome.
Well, let's compete with some rocks.
The cool thing to notice is that we can literally take this car and do this.
Point it around. I was just thinking that. Point it around the wrong direction.
We'll find its way back wherever we want it to go.
There it is. It made the turn. Yeah, that's the driveway right there. We'll see how close it gets. Should find its last waypoint and stop here any second.
Here it is.
Nice. Alrighty. I'd say it's a success.
Alright, so we just took our autonomous vehicle around the block. Had a few issues, we had to help it out, but that was just because of the inconsistencies of the waypoints that we located on Google Maps, and the fact that the battery level is varying, so our steering isn't exactly identical for every run we do. But overall, it was a success. I mean, it made it all the way around the block just with us helping it back on the road. If we threw a few sensors on it, you know, maybe it'd be able to detect the road and we could just let it go. But this is a good proof of concept, and now we will take our design further. So in future episodes, look for bigger and better things using GPS.
That's exactly what I was going to say.
So thanks for watching, and we'll see you on the next episode.